never be sorry for smiling. Okay, so last time we were clearly with fiction. So this time I wanted to see how you managed with non-fiction, factual based. How did you get on? What did you find easier, the fiction or the non-fiction? The fiction, yeah. This is normal. I'm very glad that you said that because fiction asks you to visualize. So you can get mental pictures in your mind. You can actually see the pictures. Non-fiction is very fact-based. As I say, I teach year 5, and when they struggle with non-fiction. Okay, so let's actually have.
I read this 2 times.
Okay, you read it twice. Okay, fine. Still a bit confusing. Yeah, okay, that's fine. So, here is our title. Lightning. Yes. So we all know what it is, the electricity in the sky that comes before the thunder. Yeah? Okay. So, we have subheadings. This is the first subheading, and I will show you on my laptop some other non-fiction that I have. What causes lightning? The reasons for it. So, lightning is caused by the movement of water droplets, so drops of water, and ice crystals inside cumulus nimbus clouds. Really, it's a very scientific name for the clouds that are that shape. That's all they are. That's just the scientific. You know the grey clouds that are that shaped? These are what we call rain-bearing clouds. So they've got water inside. So that's all it is, the grey, fluffy clouds. Okay? So here it is by the cumulus nimbus cloud, or also known as thunder.
Julia.
Pardon?
8.
Okay.
On.
Which creates an electrical charge with a positive charge, which are protons. Okay? So everything, you get quite scientific now, everything is positive or negatively charged. It's got to be, like there's a north and a south, it's got to be a positive and negative. You probably know this from science. Yes? Perfect. Forming at the top a negative charge, electrons forming at the bottom of the cloud. So, what it's saying is your protons are up here, and your neutrons are down here. As I say, everything's got the north and the south. Even this room, there's the north, there's the south, the top, and the bottom. That's all it means. So these guys hang out up here, these guys hang out down here in the cloud. Okay? So normally the protons stay at the top and the neutrons stay at the bottom of the cloud. Okay? Yep, fine. Oh, okay. So the electrons. Okay, science is not my thing. Okay, I put neutrons there in the middle. Okay, neutral. A positive charge builds up on the ground beneath the cloud. So beneath, under it. Attracted to the negative charge in the bottom of the cloud. So my science is not really my bag, but I remember with a magnet, things attract.
Yes.
Yes? So, if you have a magnet and something metal, it's attracted to the magnet, right? This is what is happening. The ground's positive charge concentrates, builds up. If something is concentrated, it gets more and more and more. I like to cook. And if I want to make a sauce, I put it onto the stove and I stir it with the heat very, very, very low. And it concentrates. It goes down and down and down as the water goes out. And it leaves a sauce that is thicker and the taste is more. So if I'm going to make a tomato sauce, if I put tomatoes and water and salt and pepper and herbs in there, it wouldn't be very nice in my pasta. It would just be very, very watery. So I leave it to cook. And the water vapor goes off, the steam goes off, and it leaves a sauce behind that is thicker. It is concentrated. Yes? Okay. So it concentrates, gets more intense around anything that sticks up. So something that sticks up from the ground, a tree. So let's think about it. There is the ground, and there is our tree. So the ground is here, so the tree is sticking up from the ground. This is what it's saying. It is attracted to anything that is higher than the ground. Here's the ground, so anything up. So, if I was so feeling, this is now up from the ground, because I've lifted it up. So, the lightning will be attracted to that. It's closer than the ground. So it will go there first. Yeah? It's coming from the sky. So it's going to hit this first, not here. That's all that means. Okay. Fiction. Okay. All right. Trees, mountains, tall buildings, umbrella, and even people. So it is saying, well, because we're higher than the ground. Ground is here. So anything that is higher than here, anything up. So trees are up, mountains are up, tall buildings are up, umbrellas, you hold it up above your head, and even people. People are higher than the ground. The positive charge streaming up from the ground connects with the negative charge reaching down from the cloud. Sorry, excuse me. So, the positive charge is coming up from the ground. The negative charge from the cloud is coming down. So, here on the ground, we have the positive on the ground. Up here, we have our cloud, and here there is a negative charge. So the positive is going up, and the negative is coming down. This is what it's saying. A negative charge comes down, a positive charge goes up. So they're going to meet, aren't they? At some point, those two arrows are going to meet. Okay. So the negative charge reaching down from the clouds and a spark of lightning strikes. So when those two arrows, the positive from the ground and the negative from the cloud meet, that's when the lightning, that is an effect of those two charges meeting. Just 10 minutes of science. Okay, so amazing facts about lightning. So by this subheading, it's going to tell us something that we're going to be surprised at. Okay, a lightning bolt is about 29,000 degrees Celsius, roughly 6 times hotter than the surface of the sun. So lightning is hotter than the sun, than the surface of the sun. Now I'm surprised by that. It says amazing facts about lightning. That has amazed me. Okay, so 29,000 degrees Celsius. Wow, roughly 6 times hotter than the surface of the sun. So the surface, this is the surface of my hand. This is the surface of the pen. So it is the top part of the sun as a sphere. So it's 6 times hotter. Wow. Lightning flashes more than 3 million times a day worldwide. So they're saying that there is lightning every day somewhere in the world 3 million times. So here is, because I teach geography. So here is the map of the world. So there are 3 million lightning strikes around the world every day. That's what it's saying. More than I expected. If somebody had asked me before I read that, and I have read it myself, and I said to myself when I read it, my goodness me, you were being tough. I would have said maybe 1 million, but 3 million. Okay, so around our globe, 3 million times. Wow. Okay, every day. It's a lot of lightning. Okay, that's about 40 times a second. So every second,
40 times.
there are 40 lightning strikes. Wow. Not all these flashes hit the ground. Some happen between or inside clouds. So some of them never come out from the cloud. They strike and stay inside the cloud, or between clouds. So we know if it is a stormy day, there is an awful lot of clouds. So some of those lightning never leave the cloud. They strike inside the cloud, and that's it. Or some happen between clouds. So in the space between them. So some lightning strikes happen there. Some stay inside. This is what it's telling us. Some between the two. Yeah? So they don't strike the ground or anything sticking up like the trees from the ground. They stay.
They can strike others? Strike each others?
Yeah. You know, there's, I would say though, because, now this is just a guess, I would think because the positive and negative charges, they would basically cancel each other out. You know, they would balance each other. But, maybe I'm wrong, who knows? So not all these flashes hit the ground. So some don't hit the trees or the ground. Some happen between, so between the clouds
inside.
or inside the clouds. An average lightning bolt can release enough energy to operate a 100-watt light bulb for more than 3 months straight. Okay, so there is an 80-watt bulb in there. So 20 watts more in that bulb for 3 months without turning it off. So there is enough energy in that lightning to operate that light bulb for 3 months, more than. So that's not as strong as that. Wow. It's a lot of energy. Understand? Yeah? Okay. Oh dear. It's been a long day. All that energy travels along a path about as wide as the thumb. So all that energy travels backwards. Only as wide as that. Now I've got relatively small hands, but that's how wide. Also, all that energy is concentrated. You know, I said to you about the cooking, taking something down and down and down. Burning off any vapor, any steam, any water that's there to make something thicker. And in the case of cooking, tastes better, stronger in flavour. So all of that going down in space, that wide. Wow. Understand? Okay, so it's saying there is an awful lot of energy. An average lightning bolt can give off enough energy to operate that light for more than 3 months. So one lightning strike hitting that bulb there would give me enough energy for that light to work, enough electricity for that light to work for more than 3 months. Without me going, okay, I'm not in this room, let's switch off the light. There is enough energy in there, enough electricity in there, that lightning to make the light work for more than 3 months.
This I understand this.
Okay, so the electricity that it's talking about is energy. So everything is energy. So we eat to give us energy, to make our bodies do what we need them to do. The light needs energy to shine, to do its job. I need a light in here or it's dark. Okay, so I need the electricity to fuel the light. The electricity gives the light bulb energy. Lightning is electricity or energy. So what it's saying is all that energy, all that electricity to make the light bulb work for more than 3 months travels along a path only as wide as this. So much energy is coming along a path this wide. So let's actually think, let's draw like a cartoon hand. Here it is. So here's finger 1, 2, 3, 4, and the thumb. Okay. So all of that energy, electricity, here it is, the electricity in the lightning is travelling through a path only as wide as this thumb. So, in effect, here is my hand. So, that's my hand. So the electricity, all of that electricity, enough to make that light bulb work for 3 months, is all concentrated in something only that wide. So all of that electricity is coming in something only that wide. So, okay, so here is an electricity cable. So the electricity comes in and goes down that cable into that box. And that's what makes the light work. Yep. That's what makes the light work. Okay, we just tested our theory. Okay, but all of the electricity that is coming down from the sky, from the lightning, is coming in only something that wide. So in a path. So think of a garden. Here is our garden. We've got our plants this side. Maybe we've got a tree. That would be nice. And through the middle, we've got a pathway. So all of that electricity in the sky is coming through a path, only this one. Understand? So that's all of that electricity from the sky is coming down from the sky, from the lightning bolt, and something only that wide. That's a lot of power in a very small space, right? Okay. If you don't understand something, promise me you'll tell me. Yeah? Good. Lightning kills about 2,000 people a year. So stay inside during lightning storms. Yeah, I do. They scare me. I don't love them. I don't love storms. The determining factor, okay, do you understand this? The determining factor. Factor, something, determining, decide. So something that decides on whether a particular flash could be deadly, could be harmful, depends on whether a person or animal is in the path of the lightning discharge. So, if you are unfortunate enough to be on this path when the lightning strikes, you're in trouble. So, if you are here, you're in big problem. Yeah? That's why it's saying stay inside. Yeah? Okay. So, you can use thunder to tell how far away a storm is. Yeah. Now, I've heard this story. Do you know when somebody says, okay, per second, it's per mile? Or, what is the comparison? It's just under 2 kilometers. So you can use the thunder to tell how far away a storm is. Next time you see a storm, count the number of seconds between when you see the lightning and hear the thunder. So the lightning comes first, and then the thunder, the noise, the thunder. So they're saying count how many seconds from seeing the lightning in the sky to hearing the sound of the thunder. Okay. take the number of seconds and divide by 5. And that will tell you how far away the storm is in miles. For example, if you counted 10 seconds between the lightning and the thunder, the lightning is 2 miles away. So, because
10 divided
by 5 leaves 2, yeah? So if you counted 10 seconds, 1, 2, 3, 4. If you counted 10 seconds between the lightning and hearing the thunder, the lightning is 2 miles away, or just under 4 kilometers away. Okay? So the less time between seeing the lightning and hearing the thunder, the closer the lightning is. Yeah? Okay. Okay? Yes? Alrighty. So, here, what we're, the types of lightning. Okay. So cloud to ground lightning. So from the cloud to the ground. Perfect. This lightning is the best known and third most common type of lightning. So common type, the more common it is, the more we see it. So we can say, oh, it is a common house cat. Normal cat. Not, something special, just a normal cat. So if something is common, there's a lot of it. So the third most common type of lightning. Most cloud to ground lightning strikes come from the negatively charged bottom of the cloud, travelling to the positively charged ground below. So as we've said, it is coming from up here. So I'm going to change that. My science let me down. Okay, fine. So here this is positively charged, this is negatively charged. So it is coming from the negative to the positive. Negative, positive on the ground. Okay, fine. All okay? I'm doing non-fiction and it's tough. It's very tough. It's a bit like when I took the walk through hell with the sat, with the hibernation habits of honeybees. Myself and my sat students took a walk through hell that day. Okay, so come from the negative charge, bottom of the cloud, travelling to the positively charged ground below. Okay, fine. Cloud to ground lightning bolts strike tall objects like trees and buildings. So lightning bolts, the typical thing that you see like that. This is a symbol for lightning bolts. So you've probably seen on things like superheroes, the Flash, it's got a flash of lightning symbol on his shirt. This is just a sign for a lightning bolt. Okay. Typically, Zeus, king of the Greek gods, holding a lightning bolt. It's a symbol of power. Okay. Yeah. All okay? Sure. It's not easy. As I say, I read it myself and I went, oh my goodness me. Okay, so cloud to ground lightning bolts strike tall objects like trees and buildings. So they're higher than ground. So something is up, it goes there first.
Not people?
Yes, they do. If there are no trees or buildings beside them, yes. It will go to what is the tallest, wherever it is. So, if you're in somewhere like the desert, you have more chance of being struck by lightning because there's not tall buildings, not so many trees, right? Yeah? If you are in a big city, chances are no, because there are more buildings, forests, there are trees, and they are higher than people. Yeah? Okay, fine. These lightning strikes can cause fire and property damage. Yeah. Well, yes, cause fire, yes, because we know how hot they are. And property damage, yeah, for sure, there's a lot of energy in there. If you're the tallest object, then lightning can strike you. That's what I said. It will look for the tallest thing. If you are the tallest thing, you have more chance. So I said in a desert, it's more likely. Yeah? Okay, fine. So we've got another subheading here. Cloud to air lightning. So going cloud into the air, not actually going to ground, staying in the air. This is, I think, what they're talking about with between clouds. Yes? So it's not striking the ground, it is striking still in the air. So cloud to air lightning is referred to as a discharge or portion of a discharge. So jumping from a cloud into clear air. Okay, so like we said here are the clouds. And the lightning is coming out like this and bursting here in the air between the clouds or underneath the clouds. So all of the energy that is inside our path is going here, not to ground. So it's just bursting all of its energy here or here. It can't go up. So it's going to go below. Nothing, gravity says nothing can travel up. What goes up must come down. So it's releasing its energy in the air, either beside it or below it. Yeah? Can't go up that way, so it's got to go either that way or that way. In with air. Yeah? So, okay. The most visually dynamic. So what do you think it means by that, visually dynamic? Or visually dramatic? So I just did a prime example. I read out what I thought it should be, not what was actually there. Remember I said to you last time, I read and I said to you, I'm also do this. I read what I expect to see, not what's actually there, and I did it there. So the most visually dramatic. So, do you know what they mean by visually dramatic? Visually is something that you see. Drama. Do you know, sometimes you can say, oh, she's a drama queen. Somebody who likes drama. I work with somebody like that. She's one of my teachers. You know, Miss Blaze loves a bit of drama. Everything. If the pen falls on the floor, there is drama. You would think, you know, something dreadful had happened. That's just her personality. She's a nice person, but this is just her personality. She will leave me dramatic voice messages, you know, at 3 o'clock in the morning. When is the deadline? You know, to have. You calm down,
Legs.
calm down. Yeah. Did I miss something? I sent a message yesterday saying, okay, year 1 and year 2 teachers, don't forget to put your activity stroke, your assessment in for next week. A quick reminder, you need to do this via Google Doc. She sent me a voice message. Julie, I know you said year 1 and year 2, but have I missed something? What do I have to do? And I said, no. As I said, it applies to year 1 and year 2 teachers only. We in the upper years are doing a project. We are not doing an observed activity. And then I forwarded my last message where I gave that instruction. But it's drama. I've got to do something else. No, calm down. No, you don't. What did I say? Year 1 and year 2. They are not doing a project. So it's something like that. Big, dramatic, over gesticulating, over, yes? So dramatic examples of cloud-to-air lightning occur when a long, bright lightning channel jumps out of the side of a cumulus-nimbus cloud, okay, and terminates in the clear air surrounding the storm. Okay, so what it's saying is, it looks amazing when the lightning jumps out of here and bursts here in mid-air. That's what it's saying. It can literally do that from the cloud into the air and burst. So it terminates, it ends. And how does it end? So that's what they're saying. You know, it's amazing to watch when it jumps out of the cloud and goes just in the air. Yeah? Understand? It is a dramatic way of actually saying that. It's actually a very good piece. It's difficult. It's difficult. It's tough. But it's actually very good, if difficult. Okay, so it's saying intercloud and intra-cloud lightning. Intercloud, so the internet. So the internet is accessible to everybody. Okay, everybody can access it. Internal. So you can have intranet inside the company. So it is a way of communicating only inside one company. So inter, you can communicate. I can send an email via internet home to England. Intranet would be only inside, say, a country. So you could have intranet here in Egypt. So you could only send emails inside Egypt. But the internet will allow you to send emails outside. So let's apply it there. Intercloud from one to another. Intra, inside. Way to go. When lightning happens between two separate clouds, it is known as an intercloud lightning, two separate ones. Like I can send internet, email via internet to England. Yeah? And when it happens with a single cloud, it is known as intracloud lightning. Internal to one, yes. Intracloud lightning is the most common type of lightning. Okay, so one, staying one cloud is the most common, so it happens the most times. This occurs when there are both positive and negative charges within the same cloud. Yep. So we've got the positive and the negative, so it's saying the positive at the top of the cloud and the negative at the bottom of the cloud. Usually the process takes place within the cloud and looks like a bright flash of light which flickers. So I've seen that. I've seen, yep, have to say, seen that inside one cloud, it seems to get brighter. There's boom, boom, boom inside the cloud. There's a lightning bolt, and it goes boom inside one cloud. Job done. Releases all of that energy into the cloud. That's it, and it's finished. Okay. Bright flash of light which flickers on and off. Yep. Fault lightning. Okay, fault lightning appears as a jagged lines of light. So fault lightning appears as jagged lines of light. Okay, so jagged, an edge. So this is where our typical lightning bolt comes from. So not smooth edge, but like this, jagged edge. So this part is jagged. It's not smooth. So you could say the knife had, if you were writing, say, crime, you know, you're writing a murder mystery piece, you could say the knife found at the scene of the crime had a jagged edge, because it had a menacing jagged edge. It wasn't a smooth knife, no. It was like that. Yeah? Okay? Perfect. So, they can have several branches, so like branches of a tree. So you would have a jagged edge coming off this way and a jagged edge here, just like the branches of a tree. Fault lightning can be seen shooting from the clouds to the ground, or from one cloud to another cloud, or from a cloud out into the air. So it can do everything. This lightning can strike up to 10 miles away from a thunderstorm.
Oh, yeah.
Sorry?